All right, so lesson 6-4. It's easy, but it's hard. And you guys don't need to be writing anything just yet. Okay, just listen to what I'm just talking about here. So 6-4 is easy and it's hard. It's easy because it is nothing new. Okay, it's translations, reflections, and rotations. It's hard because now it's multiple transformations on one graph. So whereas last week we just did a translation or we just did a reflection, this week we're going to have to figure out, and I'll show you how to kind of figure out what they're doing. But this week we're going to have to figure out how to do a translation. And then once we're translated over to a different spot, then we reflect over the axis. So it's more than one transformation in one move or in one graph or one problem. Okay, so that's why I say it's easy and that it's nothing new, but it's harder in that you've kind of got to keep straight your double move instead of just a single move. Something I want to point out, and everybody should put this in their notes, is when you see the word sequence of transformations, that's your clue, okay, that it is more than one transformation. Because sometimes when you look at a pre-image and an image, sometimes there's more than one way to get from point A to point B. And sometimes the difference in you doing it right or wrong is going to be you following directions. Because if it just says what map this transformation and it doesn't give you anything specific, then you can just do a one move if it's possible. But if it says sequence of transformations, that means even if it's possible to do it in one move, they want it in two moves. So where you might just be able to reflect it, and we'll see this here in a second in the example, where you might just be able to reflect it, that's a single move, and that might work. But if they say a sequence of transformations, you can't reflect it because that's only one move. You have to slide it or do a translation and then maybe rotate it or something to get it into the correct spot. So when you see sequence of transformations, that tells you it's more than one transformation. It has to include two of, or three, but at least two: translation, rotation, and reflection. Okay. All right. So I want you to go ahead and label these vertices because in the book they don't, and I think it's nearly impossible to see it without those vertices being named. So go ahead and name those real quick. And the reason I wanted to name them is because without naming them, it's very difficult to see this. But if I was to ask you just to describe the transformation, could it be a slide or a translation? Well, it can't. And you can just look at this for just half a second. Always look at the vertices. That's what's going to be your big indicator of what goes where. You've got A top left. A is not top left. So it cannot be just a translation. Because a translation, remember, nothing spins, nothing turns, nothing changes places. If the A is in the top left, A has to be in the top left in its new position, and it's not. So right off the bat, we can say this is not a single translation. Could it be a simple single reflection? Well, it can't because it's not even in the right place in the graph. A reflection has to either be straight across or straight under, right? Think if you open a book. If you open a book, and your bottom part of your book's down here, you've got something wrong with your book. A book just opens left to right, even, or up and down, even, but not over here, right? So this cannot just be a simple reflection. Now, it possibly could be a rotation. And to find that out, if it was a rotation or not, we would have to test it with our page 323. So we would have to name, I'll just use D because it's the easiest one. We would have to name D, and D is -2, 2. And then we would have to name D prime, which is 2, -2. Nope, sorry. 2, -3. So is it a rotation? Remember the 180-degree rule that we just had? X stays X, Y stays Y. They just change signs. Our X stayed X and changed signs, right? But what about our Y? Our Y did not. So this is not a rotation. Okay, so that means that this has to be a sequence of transformations, which means we're going to have to figure out, does it slide first, then reflect, or does it slide first and then rotate, or does it reflect and then rotate? There's a bunch of different combinations that you can try. Now, I'm not necessarily looking to actually figure the answer out to this one because I want to go over some examples first, but I just want to show you that the way we really tested this is we looked at the vertices. And we checked, where was A to A? Could it be a reflection? Could it be a rotation? You got to check some of those. But anytime you see sequence, you know it's not going to be just one anyway. So then you kind of have to start thinking deeper. This is kind of a little bit like chess. In chess, you've got to think 2 or 3 moves ahead and you got to be able to visualize it. Remember, I told you guys, like, that's where I struggle. This has never been the easiest thing for me in math because it takes a lot of kind of mentally visualizing these moves. You guys know how I am with that, right? I wrote it on a piece of paper. I made a block, the shape of my image from last week, and I sat and rotated it and played with it because I have to have it in my hand. I have to see it. So if that helps you when you're doing your homework, grab a little piece of paper, cut out a square, name your vertices, and then do what it's asking you to do. Flip it, twist it, move it. See what you can do to get it to line up. Do you have to reflect it and then rotate it? Do you have to translate it and then rotate it? Do you have to translate it and then reflect it? Do what you got to do to get your vertices to line up. Does that make sense? So whether or not you're hands-on, you can do this with cutting out a little scrap of paper and making it your shape. Or if you're mentally able to visualize it, then I feel like you kind of have a leg up on this lesson as well. All right, this is a very quick review. You do not have to write all this down if you do not want to. I'm going to go through this quick. So if you really want to have this down in your notes, just later on, go pop up the video, pause it here, and you can take the time to draw it because you're not really going to have enough time to draw it here while we're talking through it. All right, just as a review, what we've covered so far in transformations is translations. Remember, those are the slides. The main thing I want to point out here is that A is in the top left, A is still in the top left. B is in the bottom left, B is still in the bottom left. C is in the bottom right, C is still in the bottom right. Whether or not you slide it left, right, up, or down, it doesn't rotate, spin, twist, nothing. It looks identical, just moved to a different part of the graph. Okay. When we talked about reflections, we talked about that line of reflection being the most important thing about your reflection. And in this case, it's reflected about that red dotted line. And notice what happens with our vertices. A is top outside. A is still top outside. B was bottom outside of the graph. Now B is bottom outside of the graph. Notice B was furthest from the line of reflection on the left. It's furthest from the line of reflection on the right. Look at C. C started out closest to the line. When you reflect it, C is still closest to the line. Think of the turtle, right? A reflection is that orientation, that turtle flipping from his back to his front, right? His left leg was over here. When you reflect him or flip him over, now his left leg is over here, right? It reflects or flips the whole image. So when you're trying to decide if something is a translation or reflection, you've got to look at the vertice names, because without that, especially if it's a square, right? If you take a square and slide it or reflect it, is it going to look the exact same? The only way to tell what corner went where is to look at your vertice names and look at how they're labeled and where they move to. Okay. All right. The last one we've talked about is a rotation. Remember the important things about rotations. It's the degree that it spins. Does it spin clockwise or counterclockwise? And then does it spin about the origin or about the center of the shape? Those are really the only two we've covered so far up to this point. Again, look at your vertices. Okay. A was up top. Now A is on the bottom. So, but could it be a reflection? No, because it's not right underneath it or right beside it. And then look at B. B is bottom. Now B was bottom left. Now B is top right. So that should tell you that it was a spin. And then the C stayed in the middle or stayed closest to the origin, and C is still closest to the origin. Okay, so that's an example of a rotation. Again, you have to look at how your vertices are named. Okay. All right, so that's just a real quick kind of review of what we've done so far. I'm going to real quick just pop all these out so I'm ready to go 7th hour with all my little color coding here. Okay. All right, so now let's move to this first example. And for this first example, I don't do this a lot, but I'm actually going to switch over to the Savvis video because I really like the animation. And just as a reminder, those Savvis videos, anytime we start a new topic, like today is 6-4, I always put the Savvis video link on Canvas. One, maybe you zoned out and you missed some of your notes. You can go back to our in-class video that we're recording right now, or maybe the way I explained it, you're like, yep, I still don't quite get it. I can't see it. Go to the Savvis link that's always on Canvas. And a lot of times they're animated. And I'll show you today because the one we're going to look at today is animated. For those of you at home, you won't be able to see the animation part. So you'll actually have to click on the Savvis link yourself at home and watch those animations. All right, so it says Ava is using an interior design software to design the layout of her family room. How can she move the corner fireplace to the top right corner of the room? So right now the fireplace is over here in the top left. She wants it over here in the top right. Based on what we've learned so far, is there a single step move? Now, this is a drawing, a 2D drawing. It wouldn't work in the real world, and I'll tell you what I mean like that in just a second. But is there a one transformation that we could do on the drawing that would put this fireplace over in the other corner? There is. Anybody know what it is? Brady? Yeah. I could put a line right down the middle of this room, okay? And I could reflect that fireplace and it would flip over and it would be right here in this corner, right? And that'd be a reflection. But what if I want it in a sequence of events? And think about this in the real world. If I was actually in a living room and I wanted the fireplace, let's say it's a little portable one that you just plug in, right? It's not an actual fireplace built into the wall. If I want it moved, can I literally take a fireplace, pick it up, and reflect it over? What would be the problem? Eli? Well, no, I unplug it. It's not attached to the wall. Can I pick it up and reflect it over to the other side of the room? Oh, let's say I'm really strong. Any other problems anybody sees? Yeah, we move that all out of the way. That's not in the way. Anybody else? It would be upside down, right? If I take my box of candy here and I decide I want to do a reflection, right? My reflection does that. If that didn't have a lid, y'all see a problem with that? Okay, that's a reflection, right? So I don't want to reflect it because I don't want it to be upside down. So if I want it over here, right, I would need to translate it, slide it, and then make sure it's turned in whatever direction I need it to turn. So I would have to, instead of doing a reflection, which would put it upside down, which is not what I want, keep it right side up, I would have to translate it and then spin it around to where it's in the spot that I want it to be. Does that make sense? All right, so let's look at, I really like the way they do this. So let's look at this, and I really hope this doesn't mess up my recording. Sometimes it does, but that's all right. I'll fix it if it does. And let's go to this first video. Whoops. That Savvis has. And like I said, these are really good to go to, guys. If you're struggling with the concept, these are really good. They're short. They're like, look at this, 1:33. I'm not asking you to go home and watch a 30-minute video. These are fast, but they're kind of neat because they animate it sometimes. So here's what we've got.
How can you use a sequence of transformations to map a free image to its image? Think about this question during the lesson. Ava is using interior design software to design the layout of her family room. She wants to move the corner fireplace to the top right corner of the room. Did you know that you can compose transformations by applying a sequence of 2 or more transformations? How can you use a sequence of transformations to represent a problem?
So I've already decided I can't just reflect it. I'm going to slide it over and then I'm going to turn it around to where it fits in the corner. So I'm going to translate it 15 units to the right. That's going to slide it to the other side of the room. And then I'm going to rotate it. Would I rotate it clockwise or counterclockwise to get it to fit in that corner? Say it, I heard it. Clockwise, yeah. I'm going to do a 90-degree clockwise rotation.
First, Ava translates the fireplace 15 units to the right until it's in the top right corner of the room. Then, she rotates the fireplace 90 degrees clockwise around its center. Now, it's in the proper position in the room. A single transformation could also move the fireplace to the corner. What kind of transformation is this?
We've already talked about this. This is that reflection that we already talked about.
Ava can use a reflection to transform the location of the fireplace. The line of reflection is a vertical line segment through the middle of the room. We described two ways to map this particular pre-image. One is a single transformation. The other is a sequence of transformations.
Okay, so notice there was more than one way to do it. A reflection now. On a 2D drawing, reflections work. Notice in your homework, when you get to a problem where it's actually talking about rearranging a real room, reflections aren't an option, right? Because you don't want your furniture upside down. But on a 2D drawing, a reflection was an option. But if it says sequence, you know they want more than one move. And so you would have to do the translation, which would slide it over and then rotate it. So an example of this is, let's say I say, Jacob and Corbin, I want my desk, I want to rearrange my room, and I want my desk in that back corner, right? Well, we're not going to reflect it because I don't want my desk upside down. So they're going to pick it up and they're going to walk this way toward the door, and then they're going to walk this way to the back corner. That's a translation, right? They just simply picked it up, same orientation, same direction, same everything. They just pick it up, one on each end. They walk that way, and then they walk back that way, and they set it down. Well, what's the problem? I'm gonna be facing the wall, right? If I'm sitting here like this right now, and they pick the whole thing up, and they go that way, and they set it down in that back corner like I asked them to, I'm facing the wall, and I don't want to be facing the wall. What if I ask them to put me to where I'm facing the window? What kind of move would that be? They've translated me, now what? A 180 what? Rotation. Yeah. So if they rotate my whole desk 180, now I'm facing the window. What if I said I wanted to face the screen? What would they do? Rotate 90 degrees which way? Clockwise or counterclockwise? Counterclockwise. Yeah, very nice. So we're going to do the same thing with this cabinet, because this is that try it right here. So everybody's going to do this. So I've got my cabinet, and I want my cabinet to go from here to up here. Now I'm just going to do this so you can kind of see what I'm talking about. This is my pretty side of my cabinet, right? I can't reflect a cabinet, and we're not going to do that. We're going to do a sequence here. So I'm going to translate it or slide it across the room. And in this case, we are translating or translate. I think I counted it earlier. It's 10 units up. Okay, that's my first move. But what's my problem? If I translate it 10 units up and I leave it, I've got my cabinet, but where's my pretty side? Facing the wall, and I don't want that. So I have to have a second move, and that's going to do what? Just like my desk. Dayton, what do you think? Do I want my cabinet pretty side facing the wall? So what are we going to do with that? Are we going to translate it and slide it off to a different place in the room? Are we going to reflect it and turn it up on its side? Or are we going to rotate it? We're going to rotate it. So we're going to rotate. And if I want it facing the complete opposite direction, how many degrees am I going to rotate it? Maddie? 360 would put it back facing the wall again. 180. There we go. 180 degrees. Does it matter counterclockwise or clockwise when you're doing 180? Because both take you to that center or to that top. And then about the what? Do we have an origin of this living room? No, about the center. About the center of the cat. We're going to stick a pin right in the center of this cabinet. We're going to pick it up and we're just going to spin it around. Okay. So, makes sense? Are we good with that? 2 moves. It took a translation and a rotation to put our cabinet where we needed it. Okay. It took a translation and a rotation to put the fireplace in the proper place. Okay. All right. I'm going to skip this convince me and we're going to go to example number 2. So example number 2 is going to be one way you're going to have to do these problems. They're going to give you the pre-image and they're going to, in words, they're going to tell you the 2 transformations you need to make. They're going to tell you the sequence. So in this particular example, the first step in the sequence is to translate 7 units to the left. So we're just sliding. Okay. So to go from the pre-image MNPQ to the just the translated part, we're sliding, and notice what direction we're sliding 7 units to the left. So P stays where it was at, M stays at the top, or N stays at the top, M is still on the left, Q's at the bottom. Nothing's changed places, it's just been slid over. Okay. Notice how they notate this. It's N prime, M prime, P prime, and Q prime. But this isn't our final landing place, right? This is just half of it. Then the directions, step 2, tell us to reflect across the Y or X equals -3. Well, the first thing in a reflection, you can't do a reflection without a line of reflection. So the very first thing you would do is come in here and draw in your line of reflection. Always have to have that in place before you can reflect. So with our line of reflection, remember this is the x-axis and this is at x equals -3. So I know it's a line that goes right through that. And remember, x's go up and down. Okay. If it was on the left of the line, it's going to be on the right. If it was on the right of the line, it's going to be on the left. And now I want you to notice something. Okay. And I'll do this in different colors. This was my N prime and it's on the left. Right here. My N, notice how they do this. Double prime. It means it's the second move. Yes.
You said x's go up and down.
This is where it gets really confusing, okay? If you're talking about plotting points, y's rise. If you're talking about a line that you draw, x's go up and down. That's just when you're drawing a line. And it's very difficult to keep that straight because they're opposite rules. So you are correct. When you're plotting a point, your x's go left and right, and your y's make you rise or fall. But when you're drawing a line, if it's x equals -3, it can never touch the y-axis because it doesn't have a y in it. So it can't ever go over by the y-axis. So it has to only pass through the x-axis at -3. So you are correct, but just not when you're drawing lines. And that's a tough thing because you do both in this. In this one lesson, you draw lines where x's go up and down, and then you plot points where y's make you rise. So I get that it can be kind of confusing. Okay, so if we've got our prime image, which was our first move, and it's in black, and then we're reflecting that for the second move, and that's going to give us our double prime. And notice that N is 1 space away from the line of reflection, 1 space away from the line of reflection, but now it's N prime, and then the new one is N double prime. That tells you that it's after both moves. Then let's look at M. I should have done them in alphabetical order, but I didn't. That's okay. Here's M prime right here. M double prime ends up on the other side. Okay, that's M double prime. Now look at P. It's on the same point, but that's okay. Here's P prime. Over here is P double prime. And then look at Q. You've got Q prime, which is right here. It's Q prime. And then over here, you've got Q double prime. So these can get a little confusing because especially when they reflect and they overlap like that, it can be kind of hard to see it. But you have to pay attention to the names of your vertices. That's what's going to help you keep everything straight. Okay. So you are either going to be given a pre-image and asked to do a double move where you translated it and then reflected it over that line. There was the double move. The other way you might see it is example 3. They give you a pre-image and an image, and you've got to figure out what were the 2 moves it took to get there. And to do this, the only way to do it is to start comparing. Find your A's, okay? Find your B's and find your C's, okay? Could we do a reflection, which is going to flip the whole image upside down? But then that would put the A at the bottom, and we don't really want the A at the bottom, right? We want the A at the top. So we don't really want to reflect from here to down here, because that would put our A at the bottom, and that puts our A in the wrong spot. Yes. What do you think? So go over. Wait a minute. Let me see what she said. She said we're going to take the image and we're going to translate it over and down. Okay, so let's do that. So let's go over. How many? How many are we going over? Where's my counting? I already counted this once earlier today. All right, so we are going to translate over 8 units. Okay, so we're going to go over 8 units, and then we're going to go down, and I'm just going to do this really quickly so we kind of get done. That is going to put us at 5, 3. There we go. There's going to be our B prime. Hang on, guys. Have a seat. Everybody have a seat. I'm going to hold you over if everybody's up walking around and not letting me get this done. That's why the other hour was in here so long. Okay, and then C is right here. Okay, so here's our image. That was our prime. Okay, that was our first move. And then we had to reflect over to get the B to go from the outside to the other outside. All right, here's real quick what I want to show you on Canvas. Okay, don't anybody leave me yet. On Canvas, there is your assignment right there. It's your workbook pages that you need to do with the numbers. And then there are these Savvis videos. If you want to go back and watch the video for that third one that we just did, it's got a good animation as well. All right. It's due tomorrow and you all are excused.